welcome to my talk. This is MySQL, Node, and Test Containers, testing done right. My name is Scott Stroz, and I am a MySQL developer advocate. Before we get started, I need to do my obligatory I love me slide. I am a full stack developer, and I have been a full stack developer for longer than the term full stack developer has been in existence. In the entire time I've worked as a developer, the only constant that's been in my stack has been MySQL. I used it in the first project I had, or the first job I had as a web developer. And I have had some form of MySQL in production, either professionally or personally, ever since. I am a diehard New York Giants fan. I used to hate writing tests, and I worked on a project where writing comprehensive tests actually saved us on more than one occasion, so I've become quite smitten with them. And this is my dog, Murphy. Murphy's my best friend in the whole world. He pretty much spends all day, every day in my office with me. Well, I don't get to see you guys every day. Of course, that's Murphy before he became the 112-pound beast that he is now. I love having pets because in my entire career, whenever I had a problem and there was nobody around to talk to, I would talk to the dogs. And just talking through the problem sometimes helps. So Murphy knows more about databases than any other dog on the planet, I promise you. So what are we going to talk about today? First thing we're going to talk about is why should we test our code and why writing tests for code is important. Then we're going to talk about some of the challenges that exist when testing code that interacts with a database. I'm going to give you a brief overview of the Node, or the built-in Node test runner, give you an overview of test containers, setting up a test suite, you know, how we can create the test container, how do you organize our tests, running the tests, and then the last third of the talk is going to be just best practices, and those are like Scott best practices. They're not necessarily industry best practices. It's stuff that has served me well over the years when writing tests. So why should we bother testing code? First and foremost, it helps you find bugs faster. If you have comprehensive tests written for your code, the likelihood of a bug making it to production is drastically decreased. That percentage will never be zero because it depends on how well your tests were written and if they're actually comprehensive enough to the use cases that will actually exist out in the wild when your code is being used by humans. It helps in debugging. A lot of times when I would get a bug and we didn't either have a test to handle the use case or the test that was written was very poor or wasn't comprehensive enough, the first thing I'll do is I'll write a test. And then, or write a test for the way the code is supposed to work, and then I could work back in the code to debug it and get a fix in there. It can actually help in reducing code complexity. And this is one of those things where when I first read about this, I was like, no, that's wrong. But a lot of times, as developers, we might start writing some code and we might have a particular function or method where it starts to get a little bit out of control, where it's doing more things than it probably should, or some of those things need to be broken out into other functions or methods because they might be reused elsewhere. And that can actually, your test can actually help you identify that. Obviously, it improves code quality. If you have tests to make sure your code is running properly, the odds are your test is going to run properly more often than it's not, so the quality of your code is going to be a little bit better. And there are some places who actually use tests as an adjunct to documentation, so it actually helps the people write the documentation of how the software is supposed to work if they see how the tests are written and what is supposed to happen when the tests are executed. When it comes to software testing, there are two types of tests that are used more than any other. There aren't only two, but there's the two big main ones. Anybody have an idea what they are? Unit test is one of them. What was the other one? Integration test. Those are the two main types. Now, when I first started writing tests for code, it was hard for me to wrap my brain around what the difference between the two is. Like, I didn't understand, and a lot of people tend to use the words interchangeably. More, they tend to use unit testing to talk about integration testing rather than the other way around. But they are two specific things, and they have two specific uses. We're going to go over that. When I first started this talk, I was like, I need to come up with a good analogy on the difference between unit tests and integration tests. And I think I came up with a pretty good one. At least the people who have heard this talk before thought it was pretty good. So imagine you work for a jigsaw puzzle company. And you have to have a set of tests that tests each individual piece in a jigsaw puzzle to make sure that it's the right size, shape, that it has the right spokes and cutouts where they're supposed to be. I'm sure you do. That would be considered a unit test, where all you're focused on is just one individual piece of the puzzle. Unit tests should be focused on a single function or a single method, and they should be tested in isolation. That means nothing else should matter. If you have a function or a method that needs to reach outside that method to call a service or some other method or function, you shouldn't actually do that in your test. You should make sure that that's mocked, or if you have other type of data, that the data is stubbed. When you run a unit test, your unit test should just test that particular method and nothing else. Integration tests are when you test the entirety of the code together. So you test how the individual functions and methods and services and all the other code you have works together to accomplish the goal. In our jigsaw puzzle company, the integration test would be how all the individual pieces of the puzzle fit together. Now, I've talked to people before, and they're like, if you have good unit tests, you don't need integration tests. And those people are idiots, because that's not true. Because you could have unit tests that work perfectly, but when you put the pieces together, something's off. Maybe one piece doesn't fit the way it's supposed to because the specs were a little wrong. Or maybe when the puzzle's all together, there's one piece where the picture on the piece is flipped backwards. And it doesn't fit right. So that's why integration tests are important. It makes sure that everything is supposed to work together as it should. So why is testing with a database challenging? First and foremost is because when you write code that interacts with a database and you try to write unit tests for that code, you're kinda doing unit tests and integration tests at the same time. And the reason why is because you have code that reaches outside of the function or method you're testing that actually does the interaction with the database. Whether you're using an SDK or the MySQL connectors for the different languages, that's the code that's responsible for making the call to the database. And obviously, if you want to test to make sure that your code is working to store data in the database, you can't stub or mock those method calls, because you need to be able to make sure the stuff actually gets to the database. So sometimes people are like, well, it can't be unit test because it hits a database. Well, they're kind of right. But they're also kind of wrong, because you're not testing how the whole system works, you're testing how that particular function or method works. Database testing should be done on an island. And what that means is you should have a dedicated database for running your tests. I worked on a project where we did not have that. And we had about 12 developers, and it would cause problems sometimes, especially if somebody was running the entire suite of tests at the same time as somebody else. Because if there were schema changes that were made that I didn't have, I could start getting tests failing because I don't have the updated schema changes, the updated tests that the person is running. And that led to quite a few unnecessary phone calls or team meetings, like who broke the database, when it wasn't, nobody broke the database, it was just they were running some tests and the tests hadn't completed and the changes hadn't rolled back at the end of the test yet. In this particular case, the reason why we couldn't run the database on our individual laptops, which is what I actually prefer, if I'm going to be running tests against a database, I'd rather have the database running locally. That way I know it's completely segregated from anybody else. We couldn't do that because it was a government project and we weren't authorized to have copies of the database on our individual laptops. Excuse me. Another way is there might not be any way, or there might not be a good way to manage database changes or database migrations. There are tools out there like Liquibase can help you manage database migration, so it helps schema changes. So if you need to add a table, add a column, switch a data type, you can actually use Liquibase that will apply those automatically. Some projects, like the one I just talked about, we didn't have that. We had a guy who his job was to run, well, one of his jobs was to run the database changes. And sometimes he got to them right away. Sometimes it took him like 2 weeks to run the changes, and we weren't allowed to make the changes ourselves. So that's That's just some of the challenges. Those are the big ones. There are other challenges, but to me, those are the big ones that really tend to trip people up. So about a year and a half ago, I was introduced to test containers, thanks to my friend Todd here sitting in the front row. And this is the only time I think I will ever read off a slide because I can't do a better job explaining it. This is from their website. Testcontainers is an open source framework for providing throwaway, lightweight instances of databases, message brokers, web browsers, or just about anything that can run in a Docker container. So what Testcontainers does for us in terms of testing database code or code that interacts with the database is it allows us to spin up a Docker image during our testing process that automatically has an empty MySQL database ready to go. And then we can run whatever code we want against that database, and when the tests are done, you shut the image down, and then when it starts again, you're back at square one. It makes things a lot easier. So when you're writing tests for code, how many people here do test-driven development? How many people realize that you can't just write tests and then write code? You're always going to have to back and write tests. Yeah. You know what? Test-driven development is nice. I've actually talked to some people who are like, you know, when you're writing the code, you shouldn't write more tests. Your tests should be comprehensive enough. And I'm like, nobody has that much forethought to know. And if you do, then you're probably already writing the code before you're writing the tests anyway. So test-driven development is good in the fact that it'll get the ball rolling, but eventually what's going to happen is you're going to run into instances in your code where you're going to be like, crap, I need more tests. And then you'll have to go back and write more tests. So when you have your tests ready and you run, the way it should work is you start your tests, it spins up a test container running MySQL, it applies any database scripts or migrations that you may have, it runs your tests, it shuts down the test container, and then you bask in the glory of your flawless code. Notice I said that's how it should work. How it usually works is you start your tests, you spin up your test container, you apply your database scripts or migrations, you run your tests, you shut down your test container, you kick and scream and curse, and then you have to make changes to your code, and then you start the whole thing all over again. And eventually, you'll get to the point where how it should work, where you won't be cursing and you will be basking in the glory of your flawless code. So for the demo that I'm going to show, I'm actually using the built-in Node test runner. For those of you who don't know, they actually have a built-in test runner right now. It's been there since 18, but it matured in 20. It eliminates the need for third-party dependencies, and it supports syntax similar to Mocha, Jasmine, and Jest. I don't mean to imply by this talk that it's any better than any of those other testing frameworks. I have used all of them. I find them all to be very good, and if I had to pick one, I'd probably pick the Node one just because it means I don't have to install any third-party dependencies. No, for no other reason. They're all pretty good. They all have subtle nuances, but they all do the job. In my project structure for these demos, I have 3 files. I have a user repository file, which is responsible. This is actually the main part of the code that is responsible for saving and retrieving user information. However, in the demo, all we do is save it. We don't do anything else. Then I usually have a setup folder. In this particular demo, I have a ddl.js file. What the ddl.js file is that will actually set up the database once the test container starts running. My test folder, or my test file, is user repository.test.js. And then I always say, when I'm writing tests, and this is whether it's for server side, client side, whatever, I always have a set of utilities that I use that are going to help me make sure that the data, or in this particular case, the data we're using is used correctly. So in this case, the data utils is actually the way to test to make sure that the data was stored or updated or deleted in the database the way it should be. And I'll explain the differences between the data utils and the user repository when we get to that. So for this particular project, the package.json looks like this. The things you want to note is the dev dependencies has a project called Faker and then test containers. Faker is a great library in Node that allows you to mock data. I actually used to have a thing that I did on my own, so I would have another class that I would use that generated random strings, random numbers, stuff like that. but Faker's so much better because it can do it so much more streamlined. So you can say, give me a first name, give me a last name, give me a username, and it will format the data in a way that you could tell it's a username or a first name, a last name, or a username. And then for the other dependencies down bottom, I'm using the MySQL XDev API version 8.0.35. That is the latest node version of the connector that's provided by Oracle. Keep in mind that in this demo, I'm actually using the XDev API, which means I'm really not writing any SQL to do the insert in the user repository. If you're going to do something other than that, you can actually use either the MySQL or the MySQL 2 package that's available for Node. And this is our test file. Can you guys read that? You good? Don't worry, I can zoom in. So on top, we have all of our imports. The first four are importing packages, or importing stuff from the packages we included in our package.json. The last three are importing the code that I actually wrote for this demo. Now you see here, annotated by the number 1, we're starting a test suite, so we use the describe function. This is basically telling Node that, hey, here's a set of related tests, and when you pass in a string into describe, that's basically what it becomes named. So any reference to this particular suite of tests or this group of tests will have the label Scott's Amazing Test Demo. And then we have, we're initializing some variables. We have container, user repo, and data utils. The next thing we have in our test file is a before function. Now, in all the different testing frameworks, there is a concept of before all and before each. The problem is they're not all called before all and before each. For the Node testing framework, before is the same as before all, which means before it runs the entire suite of tests, it's going to run this code. If this was before each, it means it would run this code before each individual test. Now trust me, you don't want to run tests where you're spinning up a Docker image before every test, which is why this is in the before all. Now to me, the gem of this entire talk, of the thing that I think is probably the most amazing part of this demo, is item number 3, where we have container equals await new MySQL container dot with exposed ports dot start. That line of code right there spins up a Docker image and makes a MySQL database available to you on your local machine. One line of code. Now, normally you don't necessarily have to use the with exposed ports because you'll be able to actually pass in the port values that you can get from the Docker container itself. But in this case, because we're using the XDev protocol, which uses 33.0.6.0 as opposed to 33.0.6, that's why we had to expose the ports like that so that it knows what we're doing. Item number 4 is we instantiate the user repo, and here you can see we actually get the username, the password, the host, the mapped port, and the database name from the container itself. So when the container spins up, you actually have access to the information that it uses for the username, the password, and the host name. For item number 5, we call ddl.createUserTable. Anybody want to guess what that does? Anyone?
It drops everything from the token.
Yes, it does. No. That's actually how this is part of the process I would use to set up my database so that it's ready to be used by the tests. You can substitute any type of database migration process you want in this particular step. I just create a simple table, and we'll see the code for that next. And then lastly, we have data utils, where again, we're passing in the username, password, host, port, and database from the container itself. And then we have after. So again, testing frameworks, they have before all, before each. They also have after all, after each. We want to make sure that after all the tests are run, because remember, in the Node framework, without all, it is all. So imagine the all is silent there. So after all the tests are done, we're going to shut down the container. This is an important step, because if you don't shut down the container after you run your tests for the first time, you're not going to be able to run your tests again, because it'll keep throwing errors and it'll say it's already running, but then you don't have access to the stuff that you need. So this is our first test. And we know it's our first test because it's actually using the test method. So in the node test runner, remember, describe can be used to group tests or to define suites. Test is actually the test that we're running. Now, inside of describe, if you're doing tests for a particular method that has a lot of related tests to it, you can say, hey, we're testing the user repo, and then you can have another describe inside of that says, hey, we're testing inserting the data or inserting a user, and then you can have another describe saying we're testing deleting the user, and basically it'll separate those out in the results, and it makes it a little bit easier to find them when you if you use like your IDE to run the tests. It makes it easier to locate where the test is that failed when it fails, because tests are going to fail. So this first test, what we're doing is we're making sure the container is running. Now, the container object itself has a way to execute very basic queries. And in this particular case, all we do is we do select one as res. And we run that query and we verify that we do assert.equal, that the query result is equal to res line break 1 line break, because that's what that query would return. Now, something I meant to touch on before, but you can actually tell the node test runner how strict you want assert to be. In my examples, we're using the strict version, which would be like using equals, equals, equals. By default, it's equals, equals. So we're telling it that if we have a number 3 and a string 3, those should not be the same value, whereas by default it would be. And now the first test that we have first and only test we have for creating a user. So again, we use the test method. We actually, in item 13, we create a value called name by calling faker.internet.username. And next thing we do is we do a console.log, and we'll see what actually resulted when I ran these tests. Then we call user repo.createUser, pass a JSON object of name with a name property and the name value. Then the next thing we do is we have a query result where we call dataUtils.getUserByName, and we pass in the name. So what we're doing here in dataUtils is we're actually making another call to the database to verify the data we just tried to save actually saved. And then we compare that the query result has only one row, and that the result of the name property in the first row matches the name property that we generated from Faker. Yes, sir?
Why do you put the get user by name in dataUtils, not the repo?
Because in dataUtils, that's what we're using to test that our code that is going to go into production is actually going to be working. DataUtils is typically code that wouldn't be in production. And to do what you said, we'd have to test to make sure that get user by name is working by calling get user by name, which it'll make more sense in a second when I show the content of that file. So in user repo, or user repository.js, remember this is the file that has to be in production that you would call to make sure that we're saving the repo. It's set up as a JavaScript class. We have some local variables or private variables called connection URL and pool. In the constructor, we pass in the database user, password, host, port, schema name. First thing we do is we set the connection URL to MySQL x://user:password at host :port/schema name. Now that may look very similar to a JDBC string because it's very similar to a JDBC string. The thing to note here is the fact that it says MySQL X. For if you were using the regular MySQL protocol, it would be MySQL : not X:, it's because we're using the X protocol. And then we set up a connection pool. Do I need to set up a connection pool for the test that I'm running for this demo? No, but I wanted to show it because it's kind of easy to do and it's kind of important to do if you have any application that's going to run at scale. So we set up our connection pool, we pass in the connection URL, and we enable pooling, and we set the max thread size to 10, the max idle time to 20 seconds, and the queue timeout to 5 seconds. Those values are actually kind of high for this particular demo, so you'd have to tweak those, the last two, to fit your need. And then we have a method called getSession. So all this does is if you call user repo.getSession, it's going to pull a thread from the pool and give it to you so you can run your code.
That's not thread bound to the class instance?
It's not. And then we have our create user, which accepts one property or one argument called user. Now this is where it gets a little redundant in terms of if we had multiple, like we had create user, we had delete user, stuff like that. We would have, the first thing we do is we get the session. So we call this.getSession. And then from there, we need to get the schema. So here it's called DB, and then we do call session.getSchema. And then we need to get the table name, and we call db.getTable and pass in the name of the table that we're using. And then, because we're using the XDev API, and we're not using regular SQL for our inserts in our application, we actually do just table.insert. The arguments for table.insert are an array of column names you're inserting data into, and the data, or the column names have to be listed the way the data is going to be provided. And here we just say values, user.name. Again, if we did more than one column, that would be an array of the data we're inserting. And then we call .execute. That sends the query off to the server to insert the data. And then the important thing here is call session.close. In this demo, in these small tests, is not calling session.close going to be an issue? No, it's not. But if you have this code that runs under heavy load, not calling session.close can run into problems. Because if you don't close it, it's going to stay open longer than it needs to be, and your thread pool could wind up using up all its threads when it really shouldn't. So in the helper files, this is datautils.js, and the constructor is the same as what we just did. Because we want to make sure that we can connect to the database. We're setting up the same type of connection to the database. We also have the getSession method. And here, when we call getUser by name, now remember, this is only going to be called during your test. This is not code that's going to be used in production. You're using this code just to verify that the code you wrote to insert into the database is actually working. And here, you'll see we just get the session, and then we have a SQL statement. And the reason why I like doing it this way is if I use the same format, if I use the same XDev API, and there was a bug somewhere in the API, it might show that the data got written correctly when in fact it didn't. Or that it got written incorrectly when in fact that it did. So in this particular case, I like using a separate method to check the database. Same thing, even if we were using SQL in the user repository, I would have datautils running another query just to make sure that it's not using the same exact process. Like you don't want to use stuff in your user repo tests that is in user repo to verify that the user repo is working. Does that make sense? So here we actually call select ID, name from user, where name equals name. We call session.SQL, pass in that SQL, and call execute. Then I have an internal function here called this.formatRows, because the way the data comes back from doing session.SQL is kind of wonky, and it's not really the way that I would prefer it. So I actually have a function that basically takes that data, and so the way the data is formatted is you have a JSON object where one object, or one property of that is the data itself in array format, and then you have an array of the column names, and all I do is I just put it together in so that you get one JSON object, so you have ID colon ID, name colon name when the data comes back. And then ddl.js, this is the file that gets run after the test container is spun up. And all we do here is we create a SQL, or we have a SQL statement that creates a table with just, it's a named user, it has an ID that is an auto increment, it has a name which is varchar 100, sets the primary key as the ID, and then we use that in session.SQL and execute it. Again, if you have some type of migration process, if you're using a Node app and you're using something like Connect, you can actually run Connect's migrations in this particular part of the process. You don't necessarily have to manually do the SQL. Cool part about test containers, and this is not something I've played with yet, is if you have a relatively mature database, you can actually create your own Docker image to use with test containers so that if you have a Like I said, it's a mature database. You're not always starting with an empty database. So you could spin up and actually have your database as it was the last time it was pushed to production, and then all you're doing at that point is running any migrations that hadn't been run yet, which could be 1 or 2, it could be none. And then once everything is deployed to production, you can re-image the database and use that in your test containers again. So you're not constantly rebuilding your entire database and populating reference tables every time you're spinning up your tests. I think my favorite part about the Node test runner is that I don't have to remember really what the syntax is to run the tests. You just do node -- test. And as long as you have JavaScript files in a folder named test off the root for your project, Node can find it. Now you can actually add arguments to say this is where the test folder is, but I like just doing stuff so that it can be found by itself. So we call node -- test, and you'll see it says test name gauge85. That's the username that was generated from Faker during the test run. Remember, we created the name and then we logged it to the console. That was the name that was created. And on the first section, it's going to run through each suite and each test to let you know how long it took. So you see, we only had the one suite, which is Scott's amazing test demo, and then the 2 tests the container should be running and should create user, and it tells us that those were 69 and 23 milliseconds apiece. And then when you're done, it'll give you a summary of everything. It'll tell you how many suites got run, how many tests got run, how many failed, how many were skipped, and it also gives you duration. Now, you see the duration here? It's kind of long. For those 2 small tests, it shouldn't take 10 seconds. Well, the problem is when I ran this, I hadn't yet pulled down the Docker image. So the first time you run tests with Test Container, it's going to take a longer time than other points because it'll have to pull down the image before it can run it. Once it's down, it still takes a little bit longer than if you were doing a database locally on your machine, but I think it's a pretty good trade-off in the fact that you have a completely isolated database that you can run your tests against. And you'll see here we had 2 tests, we had 1 suite, and both tests passed because I wrote tests effectively. So now let's talk about some best practices. Again, I'm not necessarily saying these are industry best practices. These are things that I have found that have worked for me over the years to help me write comprehensive tests that test what the code is supposed to be doing. The first thing, avoid hard-coded values. Now, when I first sat down to write this presentation, I actually had this side say, never use hard-coded values. And then I had Obi-Wan in the background in my ear with his kind of ironic and hypocritical advice saying, only Siths speak in absolutes. So I changed it to avoid hard-coded values because I don't want to seem like I know that there will never be a test where you have to use a hard-coded value. I will accept the fact that there might be a use case where you need to use a hard-coded value, but I don't think that's possible. And here's why. I was on a project where we had an intern come in, and somebody decided that we were going to do some test-driven development so the intern can learn a little about the system. So we had somebody on our team, not me, write some tests that the intern was then going to have to write code to make the tests pass. Now I'm going to say this is a very, very simplified version of what the intern did, but the effect was pretty much the same. So here we have a test where we're testing to make sure that myObject.addNumbers, and when we pass in 4 and 6, actually returns the value 10. And the only advice we gave to the intern was, make sure the tests pass. Well, here's a problem with that type of attitude. That code will cause the test to pass the way the test was written. Why? Because we're passing in hard-coded values into the function. So technically, the intern did what we told him to do, and what he did was technically right. And we took ownership of it because he did what we told him to do. We just didn't have tests that were written good enough. So here what I would have done is I would have actually generated 2 random numbers using Faker and then passed them into the function and then verify in the assert that taking those 2 numbers added together matches the result that comes back from this function. If you have if statements in your code, if you have one if statement in a function or a method, you need at least 2 tests, one for each condition. Your unit test should only test one condition. You shouldn't have one unit test that tests when something is true and then also tests when it's false, because it becomes very difficult to figure out which part is wrong, because all you're going to find out is that that test failed, not necessarily where it failed. So if you have an if statement, I'd have one test for when the if statement is true, one for when it's false. If you have a case statement, you should have a test for every, if you have a switch statement, you should have a test for every case in that switch statement, and an extra one for when there's a default value or when none of the values actually match. Each unit test should only test one scenario. Your unit test should be as microscopic as possible. You want to keep as much complexity out of your unit tests as possible, which means you also want to try and keep as much complexity out of your code as possible. If your unit tests start getting more and more complex and you're still testing an individual function, you should probably rethink, does this function or does this method need to be broken down into other functions or methods to make the execution of the code a little bit easier to understand and for the test to be easier to write. Avoid hard-coded values, because you can run into problems where interns do what you tell them to do and just return the value that you tell them to return. This one's important, and this is one that I think some people try to, they do this because they don't understand. They're not fully aware of what the process is. But a unit test, the passing or failing of a unit test should never depend on the passing or failing of another unit test. They should always be separate. Each unit test should be, just like we have our database in an island, each method we're testing in a test should be on its own, should be in an island. And again, make sure if you have a function that needs to make a call to another method or another function that you mock that call and you stub that data or stub any data that would be expected back in that call. Because if you're doing a unit test for the user service, you only care that it made a call to the external thing. You don't necessarily care what comes back in unit tests. You would need to know that in integration tests. All of your tests should be automated. All of them. Your unit tests, your integration tests, everything. I worked on a project years ago where we had a process where all of our tests ran after code was committed to the repo. And it was actually set up that if the build failed, everybody on the team got an email that basically said, developer name killed the build or broke the build. And you never wanted to get those emails because everybody got them. You know, and we were on the team I was on was actually one of the few where if you broke the build, it was your responsibility to fix it. And the cool thing there is the fact that because the test failed, that means there was something with the code that was not expected based on the test. Maybe the test needed to be updated to address some changes to the code. Maybe the test, the new code broke some existing tests that were working and now they're broken. That was kind of a way to know that, okay, Scott forgot to run the test before he committed that code, and while some people think it's kind of mean to send out an email to the entire team saying Scott broke the build, it really made you focus on making sure you didn't break the build. And also, running tests should be part of your CI/CD process. So if you're deploying code to production, you should actually probably have a step in there that runs all your tests before it pushes the code out. And then obviously if there's a failure, then you shouldn't push the code out. So it's not just part of the, when you check in code and you run the test automatically, they should get run again before it gets pushed to production. If there's one thing I want you to take out of this talk, it's the fact that you should avoid hard-coded values. They will come back and bite you in the ass. Trust me, I know from experience. If anybody's interested, the code that I have for this particular demo is available up on GitHub. Now, it's more than just this demo. There's also a demo that uses Java, and there's another demo that uses Node with Connects as an ORM to handle the data inserts and stuff like that. Everybody good? Yes, sir.
I absolutely see what you're saying about avoiding hard-coded values. Specifically for worked-out mathematics, how would you use random values and random assertions such that you can't have for the additions, I know it's very simple.
Yes.
You can't do two random values and have the assert and you do the math yourself, and the process is way more advanced than just simple addition.
Yeah, that's. I've actually done stuff where there was math involved that was more than just adding the numbers, and essentially that would be I would write stuff in the data utils to handle that. So it would be a completely separate process. So the data utils would need to be rock solid according to the specs, so that when we tested, data utils returns the same value as the actual code we're using. Everybody good there? Sweet. So, how to reach me. I have an email at scott.stroz@oracle.com. You can reach me on Blue Sky at stroz.dev, Threads at Boyzoid, Mastodon at Stroz, and LinkedIn at Scott-Stroz. Yes, all four of those are completely different names because I like to keep people on their toes and make sure that they really want to find me, they can. And then one of the cool things about my particular job is when we go out and we talk to people at conferences or when we sponsor booths and we talk to attendees, we're actually allowed to offer a free voucher. I believe it's $175 that will allow you to take a MySQL certification exam or apply that $175 to some online training that would allow you to then pass the certification exam. It's through a group at Oracle called Oracle University. They are responsible for maintaining and creating not only the exams themselves, but the content for that exam. If anybody is interested in that and getting that free voucher, let me know. All I'll need at the end is your email address, and I can let you know how it works from there. And does anybody else have any questions? Yes?
So, at scale, you're running a lot of tests concurrently. I don't know if Node version supports that, I guess does. My naive approach would be to start a container before everything, use different lineage schemas maybe to isolate the tests.
Yep, that's one way to do it.
Any other strategies to prevent you from making the container fall over because you have to leave that?
Not that I can think of. In the 5 seconds since you asked that question, I'm sure maybe possibly I will down the road, but that would be one way that you could handle it, where you can configure it to do different schemas for stuff. Do you have a question?
Yeah, do you recommend any other libraries or other types of databases like Microsoft SQL Server?
So here's the interesting thing about this talk. You can use these same type of processes in the same type of application for MySQL, SQL Server, Oracle DB, the other open source one with the elephant, I'm not going to say their name. As long as Testcontainers has a container. Oops. Yeah, we finally got Sonoma approved at the company level. So Testcontainers has containers for MySQL, Postgres, SQL Server. They also have SDKs for Java, Node, I believe Python, and others. So a lot of the concepts I talked about here today will work with other database systems. It's just in order for Oracle to allow me to come and talk to you about it, I had to say MySQL. But you can use them elsewhere. Again, if you look at the Java code, it's still using MySQL, but it uses, I forget what testing framework I use there, but very similar layout and functionality that we have. And you can easily substitute in whatever your database or flavor is, as long as there's a test container that supports it. Anything else? Another one, good.
So earlier you were recommending ways to optimize deploying the schema or the ETL to the database. So we have a massive schema, so it would take forever to write all this code. So we use Redgate for our source control. I don't know, how would you get that to work where you do a Redgate deployment as a part of the test runner?
I'm not familiar with exactly how Redgate works, but like I said, you can actually so by default, when you spin up a test container, you have a pristine, brand new database. You can actually create an image, and it's not something I've done, I just know it's possible to do with test containers, where you actually already have an existing database so that when you spin up, you have your database. And then from there, you could probably run your Redgate process on that version of the database, so it only applies the changes that it needs. And then if you're gonna do that, what you should probably do is, after each production deployment, update that database image, so that it always has the most recent data. So basically the thought there is the database version that exists in your container matches what's in production. And then,
Is it what is?
What is Redgate?
Oh, it's a tool that does like SQL version control.
yeah, it's similar in function to Liquibase.
So some tools like Liquibase have like reverse engineering.
Yes. Yep.
Basically export an entire operation for an existing schema, and you can just include that as part of your
Yeah, there's a couple ways you can handle it. Once your database gets like pretty big, it's probably going to be better to investigate using a custom image with test containers than trying to run all the migrations. I can actually see some projects where if you just ran the migrations, it's like you run the test, you go get coffee, you come back, maybe the tests have started, depending on the size of the database. And you can also, if you use something like Connect, which again that's a node-based ORM, you can actually populate reference tables too with that. So if you have like a user type table, you can create the user type table and then populate it all as part of that beginning process where I just called create table. So there's a lot of different things that you can do. Probably the best is going to be to look into how to use a custom image in test containers. That's probably going to be the fastest way and the most consistent way that everybody is using the same database to start when their tests start. And again, each production build, you should change that image. You're welcome. Anybody else?
Testing question, but they can wait for that.
Okay. All right, if nobody else, thank you very much.